So, hello, Skyfi Lab team members. Uh, this video is made by the Chaurasiya of Dayalbagh Education Institute as the part of the final assessment of a foundation design course from Skyfi Labs. It is assessment. So, in this assessment video, I will explain how to design a foundation. Of in this video, I will cover the isolated foundation. So our question will be design an isolated footing for the following cases. Here the load given, the dead load 300 kilonewton, live load 140 kilonewton, dimension square column and 500 mm into 500 mm, and reinforcement bar size 20 mm. The material which will be used, material property, the safe bearing capacity of the soil is 100 kilonewton per mm per meter square. Concrete grade which we will use in the footing, uh, M30 grade of concrete, and rebar grade HYSD 1 4 415. And the consider we will consideration the allowable settlement is 1 centimeter. So first of all we will we will we will have to find the area of a footing and subgrade modulus. So for the area, we all know about that the area which is equals to total load upon SBC, यानी कि safe bearing capacity. So a load is given 300 kilonewton to 140 kilonewton. So here 300 plus 140 kilonewton and SBC is 100 kilonewton per meter square. We will divide it, we will get the 4.4 meter square. This is a required area. So according to this, the length of one side root 4.4 meter, so we will get the 2.09 meter. So for the sake of comfortability, we will consider the 2.5 meter. So according to this, the area of the footing will be changed. So the here it is a diagram of the footing, foundation. The length is 2.5, and the breadth is also 2.5. So the distance from the edges, as we all know, the footing the foot in the column size is 150 by 500 by 500 mm, so that will be considered the center. So from the center part of the column to the wall, to the left edge of the wall, the distance will be 1.25, and the same as the right side, and same as the top, and same as the bottom. So, and what we will have to find subgrade modulus. The subgrade modulus which is equals to safe bearing capacity about the allowable settlement. Allowable settlement is 1 centimeter. Here is a 1 centimeter. Okay. So SBC is 100 kilometer per annum square. Here it is a centimeter. We will first of all have to convert the centimeter into the meter. So 1 centimeter is 100 1 upon pi 100 meter. So the 10 to the minus 2. So we will divide. Then we will get the 10 to the power 4 kilonewton per meter square. So okay. And then after this, we will have to find the column strip width. The column strip width is 0.25 L or L2, whichever is less. We will consider the that which is less. So L1 is this is a we will find the length 2.5, then history will multiply this, so that it is a less, so we will consider the this. And this is a data which we will use in the whole design of the footing. So let's move to the safe software to design the foundation. So here it is a new model. Click the new model. It is taking some time to open. I use the build in setting way because we are using Vim, and we will, here it is a display unit. We will use the metric SI unit. Okay, we will construct this foundation in the India, so we'll consider the Indian default and the steel database, and the what will be using in the IS 456200. What is this IS code of? So okay, here it is our so in this panel there is some default structure objects. We will select the single footing. Take single footing, left edge distance, and the distance we all know, which is 1.25, 1.25 here also, 1.25, 1.25. Okay, subgrade modulus we will find here in this PDF. Yeah, the subgrade modulus is 10 to the power 4. Okay, so here we will click the 10 to the power 4 and the thickness, which is the thickness of is 500 mm. So, and this is another thing. We will not yet change anything else here. And up here we will set up the grid lines. What we will say, what will we be set here? Here we will set the grid lines. How many grid lines we will take in the x direction, and the spacing between the each grid lines. The spacing between the each grid lines here, it is mentioned clearly. It is mentioned clearly here. So what is the mentioning here? Here it is the number of a grid line in x direction, number of the grid in y direction. 4, we will take the 4, no change, and the distance between the 4 meter. So if there's some slightly changing here. Okay, and the load size is equals to 500. Also the load size also the 500. Okay, footing size. Okay, here. Okay, it is taking some time to here guys. It is our footing, it is a foundation, and here it is a column by 50 by 50. So first of all we will define the properties. So M20 grade of concrete we are using here. So first of all we modify M20 grade of concrete. Here concrete weight of the unit is 224 point, the weight of per unit is 25. Okay, and bit of the 25, and the elasticity which is and here we will change the coefficient to the thermal expansion .000055. Okay, and and here the and some additional modification will be there. Will so here change the M30 grade of concrete, so the days compressive strength, the characteristic comparative strength we will find after 28 days, which is 30 ampere. Okay, so it is 30. Okay, now click the OK, and the material property and the M, here it is designed, and the material property of M20 has been defined. So now, and we are using the HYSD 145 reinforcement bar material type. So here will change also the properties. So HYSD bar, the unit weight, you know what, the weight per unit volume, which will be, here it is a modulus of elasticity. Okay, modulus of the elasticity and a design property. Then we will have to some more property, modified some more property. So here in this we will change the two properties here, the minimum yield strength and minimum tensile stress. So which is Fy or Fu will change here, but it is by default has changed. So click the OK and OK, and this OK. Now the material property has been defined. After this we will have to define the slab property also. What is the slab? Slab is a section, is a kind of section. So the slab will be in the section column, section property column. Here it is a slab section. We will click there. Here we will change the footing and stiffness. Okay, it is a stiff footing and stiffness. So first click the footing and modify footing 1, which is the footing is made up of 30 grade of concrete, and the thickness of the will be 500. Okay, and here the click OK. Okay, and now change the some stiffness, modify for the stiffness we will use the M30 grade of concrete also, and the 500 here we will change the 500. Okay, click OK. Okay, now we will define the material property and the slab section property. Okay, and then after this we will define the load patterns. Okay, here we will define the load patterns. So, and the dead live load, and here dead load and live load. So the dead load 5 and the live load also 0.0, which is clearly which has already mentioned, so there is no need to change this. So here right click OK, and then after we will have to define the load case. Okay, it is a load case. Load case also dead load and live load also clearly already mentioned, so defined. So here click OK, and after this we will have to define the load combination. Okay, so here we will have to define this, so we will add a new combo. Here we will combo some live load and dead load also. Okay, so here we will change the live load and multiply by the scale factor 1.5. okay, click the 1.5. okay, okay, ठीक है, okay. Now we will select the strip, select the strip design strip layer. Okay, so here we will go the properties, and the properties we will to design strip layer. Design strip layer. Now select, okay, after this we will define the soil property. Okay, we will define the we will to draw what we need to do. Draw strips, draw design strips. Okay, so here it is the design strip. First of all, need to change the strip A 500 mm, okay. We will have to draw the so click here and then join here and right click to exit from this, and now the define the grid of B also. Click here and join here and right click to after the defining the properties, after the defining the design strip layer, click here, we will have to click here. Okay, so layer B and layer B, here it is shown the two layers to show for the tendons and the strip slab rebar support lines. Okay, so what we will do here, design strip object, here it is. So what label, show width, label, show width, and the show station also. Okay, then apply to all windows nahi. Okay, sorry, here it is. Here, here it is straight lines. Okay, so first of all, and then we will have to close this. Okay, apply, then here close it. Okay, after this we will have to define the slab section also. Slab section. Okay, after this we will have to assign the load. Okay, so load data, where is a support shall load. Okay, frame load. Point load. Okay, frame load, we will kill the point load. Okay, apply, correct. Okay, okay, after applying the load, we will have to analyze the model which we had as run analysis. First of all, after this we will have to check. First of all, we'll save to the file. We'll save with the name of design assessment. Okay, save. It is taking some time to design. Guys, here you can see the load profile, or the load profile with the help of the diagram. At the center, the maximum load will applied on the soil, and as we move further from the center of the column, the color will changes, and this color signifies the load value. Okay, so this is the end of our today assessment project. Thank you very much.